All right. So we have in this problem, we have an iron bar that is at some initial temperature and it has heat or energy removed from it. And when heat is removed from any material, the temperature will drop. So how are we going to do this? Well, there's a formula for specific heat that is constructed, and it reads Q is equal to MC times change in time. And what this means is that the change in heat is proportional to the change in temperature. So since we're losing heat, we can go ahead and modify this and call this negative Q is equal to MC change in T, which will be MC times temperature final minus temperature initial. And we can go ahead and say that negative Q over MC is equal to T final minus T initial. So if the question is asking what's the final temperature after the heat loss, we can just isolate the final temperature variable and say that the initial temperature minus Q over MC is going to give us our final temperature. All right, so we have the mass of iron, which I call MFE. Now we just need the specific heat. So the specific heat of iron, there's different units for specific heat, but in this case, we're going to be using the units of joules kilogram per Kelvin, and that's going to be 470 joules per kilogram times Kelvin. Okay. So if we're going to, there's a problem here because we have the initial temperature is equal to 29.5 degrees Celsius. And we need to go ahead and change that to Kelvin to match the units on the specific heat. So what we can do is we can say, okay, the initial temperature in Kelvin is just going to be 29.5 plus 273.15. And it should be in Kelvin, it should be 302.65 degrees Kelvin. Now we're ready to find the final temperature. So the final temperature is just going to be 302.65 Kelvin minus the heat lost, which is 87.3 joules over 0.456 kilograms times the specific heat, which is going to be that 470 joules per kilogram Kelvin. Now, do our units match up? The joules cancel with joules, kilograms cancel with kilograms, and we're left with Kelvin because Kelvin will go on the top since we're dividing by a fraction. So it evens out. And after the calculation, you should get something like the final temperature is 302.65 minus 0.41 degrees Kelvin. And it's a very small temperature change. And basically putting this into Celsius, the final temperature will be 29.1 degrees Celsius. Okay. Now it's a very small change, but compared to the mass of the iron, 87 joules is not a lot of energy. So it makes sense that it's a very small temperature change. Hope this helps.